Hi guys, welcome to another video. In this video we will learn how we can simulate our circuit in KiCad. So let's launch our KiCad 8 over here and let's create our project by going to file and new project, and let's name it as amplifier, because today we are going to simulate inverting amplifier circuit. Let's just save this and let's open our schematic editor, and let's click on this add symbol button to add the symbol of operational amplifier. And we are going to make inverting amplifier, and we will use the spice model of the operational amplifier. So it's just loading the footprints now. So over here on the filter we can search for spice, and we will see over here this is the simulation spice library which have over here this operational amplifier. So let's hit OK and place over our canvas. And now we want to add a resistance, so click on the add symbol and over here write RES, and this is the resistor. Click on this and let's place it over here. So let's leave this add symbol tool, click on this and let's rotate this, and let's move a little over here and let's duplicate this and let's place it over here. Now what we need is we want to connect this pin number 5 with this resistance, and over here this resistor at pin number 2, the inverting input, and let's connect this with this one. Now we want to add ground symbol over here. So for doing that, let's leave this tool, click on this add power symbol libraries, and you can search over here GND. This is the ground symbol, so let's hit OK and place it over here. Let's just rotate this, rotate counterclockwise. Let's rotate once again, and now let's connect this ground with this plus symbol. Now the next thing is we want to add VCC and Vee over here. So let's go to this add power symbol library, and over here let's search for VCC, and this is the VCC. Hit OK and let's place it over here. Again click on the canvas and let's search for VEE, and let's select this and hit OK, and let's hit R on the keyboard to rotate this and place it over here. So let's connect VCC and VEE by using add wire, and click on this. This way you can connect this VCC and Vee. So our circuit is almost complete. Now we want to add labels for the output and for the input. So for doing that, add this global label and write over here out, and let's hit OK, and you can place this label over here. Similarly, again click on the canvas and let's add a global label as input. So let's rotate this, place it over here, and let's add wire between this resistance and this input. Now the next thing is we want to add KiCad models for VCC, VE and input signal. So for doing that, go to this add symbol library and search for VDC. For the VDC, over here you see simulation spice, and this VDC we are going to use this voltage source. So click on this and hit OK, and let's place it over here, and let's leave this add symbol, and let's make a duplicate of this simulation of model. So click over here, and the next thing is we want to add some input signal or model for giving this input signal. Going that, click on the add symbol, and we want to give sinusoidal signals. For that we should have V sine, that is voltage source that is sinusoidal. So click OK and place it over here. Now the next thing is we want to connect this in our circuit. So let's connect this with this one, and let's make a copy of this. Let's click duplicate and place it over here. Similarly, select this VE and duplicate and place it over here. Let's make a duplicate of ground and let's place it over here. And we want to now we connect this circuit by going over here. Let's connect VCC with this one and VE over here, and let's connect ground over here. And now in this way we have studied in our previous videos that this global label is connected with this one, this VE with this one, and this ground with this one. And now it's time to connect this input signal with this global label. So for doing that, click over here and let's make a duplicate and place it over here. Similarly, click on this ground and hit duplicate, and let's rotate and place it over here. So let's click on the add wire tool and let's connect with this over here and this ground with over here. Now let's save our work. Now you can see that we have completed our circuit. As you can see, if I choose the net highlighter, if I click on this, you can see that it is connected with VCC, ground with the grounds, V with the V, and in with the in. So let's leave this highlighter tool and let's save this. Now we have to add values. Let's say for this resistor I am going to choose on the left side. You can see over here that properties dialog box opens, and you can even change value by clicking on this and going to properties over here, and you can write value over here, let's say 20k, and hit OK. The other way is, let's select this resistor, and over here on the left side you say it's reference designator R2, and you can give it a value 10k and click on the canvas. In this way, let's again do this. Click over here and let's write over here 10k, and you can see that we have changed the value over here. Similarly, let's add value of this VDC, and let's click on this, go to its properties, and in the value section let's say we have 15 volt and hit OK. Similarly, if we hit E into the properties and give its value again 15 volt and hit OK. Now you have seen that we have 15 and 15 over here. when as a result we have VCC of plus 15 and VE of minus 15. And over here the sinusoidal source, it has DC equal to 0, amplitude equal to 1, frequency of 1 kilohertz, and AC is equal to 1. So it's a sinusoidal, it will give a voltage that is sinusoidal with an amplitude 1 and 1 kilohertz frequency. So let's save our work. Now the next thing is we want to simulate this circuit. For simulation, go to inspect and go to simulator over here. So first of all we have to create a new tab containing simulation analysis. So let's click on this. As you can see that we have different analysis type because we have no time involved in our analysis, so we will choose transient analysis. In the transient analysis, let's say we want to choose time step as 10 microsecond and let's say final time as 10 millisecond, and let's leave all the things as it is and hit OK. On the right side in the signals, there is a list of signals that you can click over here to analyze, and the graph will appear over here. Let's say if I want to check input voltage and output voltage, as you can see input voltage this one and the output voltage over here. So I have checked this, that I want to see the graph of input voltage and output voltage. After doing that, you can click on this run simulation, and you can see over here that we have a graph in which there are two different sinusoidal waves. The red is the input and the green is the output. So as you can see that we have used inverting amplifier. I have drawn circuit that it will invert the input signal. So you can see that we have there is a inversion of the output signal, and you can also see that we have added a gain of 2, as you can calculate using this inverting amplifier formula, that we have a gain of 2. Over here you can see that as we have input signal that reaches to 1 volt, and the output is inverted and is 2 volt. So in this way you can see the graph of input and output. Let's perform a small signal analysis over here. Let's just close this and add another analysis tab. And over here if you go to, this is the AC small signal analysis, which will give you the response of the amplifier with respect to the frequency. So let's say a number of points per decade, I want to take 10 points, and let's start the frequency from 10 hertz to let's say 10 megahertz, and let's hit OK. And for this what I want to see is the V out gain and V out phase over here, and let's again run the simulation. So over here you can see that on the left side over here the gain is in dB, and on the x-axis you have the frequency till 10 megahertz, and you can see that as the frequency increases the gain of the amplifier decreases. So in this way you can simulate different points on the in your simulation and can see in their graph. Over here you can see different types of signals as well over here. So what we have done today is that we have drawn a circuit with the inverting amplifier configuration and have fed a sinusoidal signal and have run the simulation. That is, we have done a transient analysis and then we have done a AC small signal analysis. And you can see over here, let's say if I increase the amplitude of the sinusoidal signal from over here, you can see amplitude is 1 and let's say I change it to 2 and hit OK. Let's save this and again go to simulator, and let's choose V in V out as it is, and let's run the simulation. Now you can see that we have red line that is reaching the maximum peak of 2 volt, and when multiplied by 2 and invert it, then we have minus 4 volt. So in this way you can run a simulation in KiCad, and it uses ngspice. Spice uses spice model to run the simulation of your circuit. This is how you simulate your circuit in KiCad.